everyone. Good morning. I said good morning, everybody. Good morning. All right, so we are going to get started with math, okay? This week, our standards, who want to read our standards? I'm going to pick a number. Okay, go ahead, Cameron.
Solve real-life problems involving addition, equivalence, comparison of fractions with denominators of 10 and 100, and comparison of this equal numbers as 10 and
Okay, pause right there, okay? Because we see a lot of words that we are unfamiliar with. Raise your hand if you see a word that you do not know or you're not familiar with. Raise your hand high. Thank you, Okari, for being honest. Thank you, Anaya. Thank you, Tisha, Amina. Yes. So what we're going to do, we are going to deconstruct. We are going to deconstruct our standards, okay? We know what deconstruct means. What does that mean? Break it apart. Thank you so much. Break it apart, okay? So let's do this first standard. Let's break it apart, okay? So, solve real world problems. So what word do we not know? So Miss Allen can circle it. What word? What about this big old word right here? Equivalence. You know what I mean?
Yeah.
What does that mean?
Something that's equal to.
Something that is equal to. Okay, okay. So I'm gonna replace it with equal. Okay. What about comparison? Do we know what it means to compare?
Yes.
What do it mean to compare?
Put two things and see what's common and what's not. Like see what's alike.
So when you're comparing, you're checking to see what's different. Okay? When you compare, you're checking to see what's different. So what's equal and what's different? I'm gonna say different. Okay? Fractions with denominators of 10 and 100 and comparison of decimal numbers as tens and hundreds using part whole strategy and visual models. Okay? So we have our visual models, do we? Hold them high. You need to have 2 base 10 blocks and 2 base 10 rods. Okay? So we have our models we're going to use. Okay? Go ahead and put those to the side, all right? So we're going to solve real life problems involving equal, equivalent, or different fractions with denominators level 0, okay? With denominators of base 10 and 100 in comparison of decimal numbers as tenths and hundreds. Do we know what decimal?
Yes.
You know what a decimal number is?
Yeah.
Let me see. Let me give some class dojo points to someone who can tell me what a decimal number is. What's the decimal number of one? No, I'm gonna start off small. Of 10. How can I write 10 as a decimal? Tell me. For 5 class dojo points, tell me, Michael.
0.10.
Excellent. Okay? 0.10. All right? This is the decimal form of 10. Okay? So, what about 25? Tell me, Damani. 25. How can I make 25 as a decimal? Decimal number. 0.25. Just like that, okay? So this is what we're going to work on today. And there's a little bit more to that, but we're going to find out what else, okay? So here we go. Read the second standard for me. Owen, read the second standard. Demonstrate
And explain the concept for equivalent fractions with the
mhm,
of
10 and 100
10 and 100 using
concrete materials. Mhm. Okay. Yes. So for those who did not hear, let me read it a little louder for you, okay? Demonstrate and explain the concept of equivalent fractions with denominators of 10 and 100 using concrete materials and visual models. Add two fractions with denominators of 10 and 100. Now this one sounds very familiar to this one. Can anyone tell me what may be different from this standard than this standard? I see some key words that it's telling us to do in this standard that it's not telling us to do in the first one. It wants us to do what? Demonstrate and explain, okay? Demonstrate and explain, okay? I'm gonna put a star by that. All right? Demonstrate and explain, okay? And our last standard is represent, read, and write fractions with denominators of 10 and 100 using decimal notation and decimal numbers to the hundredths place as fractions using concrete and drawing, okay? So today we're gonna be a little hands-on today. So you should have 3 things on your desk. We should have our math journal. We should have our base 10 blocks and rods. And we should have our practice worksheet, okay? 4 things, okay? My bad, 4 things. And our pencils, okay? Thank you so much for correcting me. Okay? So, we went over the standards. Now let's go over our learning target, okay? By the end of this week, we will be able to demonstrate and explain the concepts of equivalent fractions with denominators of 10 and 100. We also are going to be able to represent, read, and write fractions with denominators of 10 and 100 using decimal notation, decimal numbers to the hundredths place as fractions using concrete materials and drawings, okay? So everything we just went over, you will be able to do by the end of this week, okay? All right, so what we're going to do right now is in our math journals, we need to write down some of these key words, right? We have to be able to understand what the words mean so that we can use them correctly. So on your next blank sheet of paper in your math journal, I want you to put subject, right? And we are talking about denominators, denominators, 10 and 100. Okay, we're also talking about equivalent fractions. Equivalent. Okay. So that's gonna be our subject. And then I want you to, of course, always put your name and today's date on your paper. And Miss Allen's gonna pause right there to make sure everyone is following along. We're just setting up our page right now. We're just setting up our page. Yes. Okay. I'll write down some key terms. so we can get our terminology together. All right. Thank you. Put your thumbs up. You done setting up that page. Okay. So now, some of the keywords that you will need to know is a decimal number. Okay. So our first vocabulary word, skip a line, and we're gonna put decimal number. Oops. Got a bad marker. Decimal number. We need to know what a decimal number is. That's part of our standard. A decimal number. So a decimal number is a number that consists of a whole fraction part. Okay? Exactly what we just did. I had two people give me an example of what a decimal number was, okay? I asked them, what was the decimal number of certain numbers? We used 10 and 25, remember? Yes. So at the bottom, I want you to put example. And then, instead of, no matter of fact, we're gonna use one example that we used, which was 10. And then I want you to give me another example with your own number. So the first number, this is Miss Allen's example, is 10. I know the decimal number for 10 is 0.10. Then I want you to create your own example at the bottom. Okay? This is your own example. Your thumbs up, okay? When you're done, put your thumbs up to let Miss Allen know that you are done. And you want to share your answer. still be are you positive? Alright. Okay. Alright. So, what 0.10 looks like is this right here. Everyone hold this up. 10. Okay? I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, okay? So these rods right here, these base 10 rods, equals up to 10, okay? So the decimal form for 10 is 0.10. So Cameron came up with something, he is past us, but he did 100, okay? So everyone hold this one up. These are our base 10 blocks that equal 100. 10 times 10 is how much? 10 times 10 is how much?
100.
Yes. Okay? So this is equal up to 100. The decimal form for 100 is 1.00. 0, 10s, 0, 10s, 100. 0, 10s, 100. Place value. Who remembers when we did place value? Raise them high. Place value. 0, 10s, 100, thousands. Yes. Raise your hands. Thank you. Alright. So, here we go. We have decimal numbers. The next vocabulary word, key vocabulary word that we need to know is, that we already know, equivalent fractions. Equivalent fractions. Equivalent fractions. Okay. And we know equivalent means the same, right?
Yes.
Okay, so the thing that you do need to know about equivalent fractions is it's going to have the same different numerators. So the top number is going to be different numerators. But the same denominator. Okay. And Miss Allen example. Miss Allen example is, let's see, 5 tenths plus 5 tenths. Now the 5 tenths is equal to 1 half. Wait a minute. No. 5 tenths is equal to 5 tenths. We know them, they are the same. Equivalent, but different numerators. I think I need another example. Yeah, I know. of equivalent fractions? 36. What in our definition? Oh, I'm sorry. Miss Allen got that wrong, okay? It's gonna have different numerators and denominators, but equal the same value. It's okay, teachers make mistakes too. Different numerators. Thank you for correcting me, Michael. Give me 1 second. But the same value. Alright, so thank you for correcting me, Michael. Miss Allen got a little confused, okay? Equivalent fractions have different numerators and denominators, but they equal the same amount, okay? They have the same value, okay? So mine is 1/2 is equivalent to 3/6. Here go my 1/2. Here go my 1/2. Right? Head up. Y'all better talk about math. Mathematical. And here go my 3/6. Okay? Now I wrote my example. Go ahead and write your example underneath equivalent fractions. Okay, so we're gonna focus on these two vocabulary words today. Decimal numbers and equivalent fractions. Put this to the side so everyone can finish writing. Put your thumbs up when you are done so that we can move on. Okay, still waiting on a lot of people. Wait. Don't move too fast. Alright, let's get started. Let's get back to it. So now I'm going to show you a quick video about fractions and denominators of 10 and 100, okay? So all eyes should be here. Thank you. That's too loud.
My name is Owen. I hope you are doing great. As you already know, I travel with my family around the world. Right now, we are in Netherlands, which is a country located in northwestern Europe, also known as Holland. Did you know that the Dutch produce billions of tulip bulbs each year? 90 hundredths of the world's tulips to be exact. Yes, This is a fraction with a denominator of 100. Well, today we're going to learn how to add fractions with denominators 10 and 100. The good news is that adding fractions of these types is the exact same process as adding fractions in general. As a matter of fact, the biggest difference is that
Alright, so let's take a pause. We already know how to add fractions with unlike denominators, right? What do we need to do when we are adding fractions with unlike denominators? Tell me, Jakayla. Say it again. Okay. We are going to times it by 10. But why are we timesing it by 10? Good job. Help her out. Tell me, Marco. So it can be, so the denominators can become equal, yes. All right, but what is that called? We're finding the
GCF?
Oh, yes. Yes. Okay. So it's the same thing as I'm gonna call him Sam. It's the same thing what Sam said, okay? Look at this problem right here. We have A over 10. A is just a variable. Plus B over 100, okay? They have different denominators. But we're gonna do it the same exact way we've been doing it. So let's figure out how Sam is going to solve this problem.
finding a common denominator is easier because 10 and 100 are multiples of each other. Okay, first let's consider the steps involved when the fractions we are adding have the same denominator. When this is the case, we simply keep the denominator as is, add the numerators as indicated, and then simplify the result if necessary. For instance,
We have that word again that starts with an S, simplify, or which means what? The money. When I say simplify the number, you're gonna break it all the way down, okay? Cut it in half until you can't cut it in half no more, right? Yes.
if we were adding 4 tenths and 3 tenths, we would keep the denominator as 10, add the numerators, and then simplify if necessary. We see that 4
So let's solve this problem because we are smart and we already know this answer, okay? So I want everyone to just scream out loud because some people
Seven.
give me the answer. 7 tenths, okay? 7 tenths, okay? 7 over 10. When the denominators are the same, we just move it over and we add across, okay? 7 tenths. Can we simplify 7 tenths?
No.
No? Put your thumbs up if we can simplify 7 tenths. You believe that we can. Okay, put your thumbs down if we cannot simplify 7 tenths. Okay, so let's see what Sam is going to say about this.
4 tenths plus 3 tenths are equal to 7 tenths. That's pretty easy, huh? Well, let's take a look at what we do when the denominators are not the same. When this is the case,
So I
we
guess
just
we
need to
don't
find the
simplify, so
common
that means y'all was
denominator by
right.
finding the
Just
smallest
on
number.
back.
Both denominators divide into evenly. Now when we have a denominator of 10 and 100, we do the same. Remember, denominators 10 and 100 have a common denominator of
Find
100.
a common
We simply multiply
denominator.
both the numerator and denominator by the number we need to multiply the denominator by to get the common denominator. For instance, suppose we are adding a over 10 plus b over 100. We know the common denominator is 100. To make 10 into 100, we multiply by 10.
So the common denominator of 100, okay? So I actually want us to work this problem out together, okay? Let's work this problem out together. They're gonna give us an example. Let's see.
Therefore, we manipulate a over 10 by multiplying the numerator and denominator by 10. To get 10a over 100, we don't have to do anything to be over. We have a common denominator of 100. For example,
We're gonna create a problem. All right, pencils in your hands. Zella The number is going to be 20. No, it's going to be, let's see, 7/10 plus
14.
let's say 20, 100.
What? 21. Oh, I know it. This is
Wait.
easy. This is easy. I know it.
I want you to work it out before you say a problem. Say the answer, okay?
This is easy.
Work it out on your own paper. So 7/10 plus 20, 100.
This is easy. This is my first time hearing you say something.
7/10
So,
plus 20, 100. Show me you can do it.
this is easy. So, hold on. Do not answer. Please don't answer. Hold on. Don't answer. Bruh. Okay. What is it? Foul. I think foul.
Take it. What I do want to say, what Miss Allen is going to say is I need for you to go back, make sure your math is correct. Are you done? Make sure your math is mathing. Okay? I appreciate everyone who is trying. Even though they having difficulty, they said, I'm still going to try. And I appreciate that. Turn on one of these lights. Thank you. This is pretty easy. All right, so I need you all to help me through this. What should I do first? Find the greatest common denominator. The greatest common denominator. Okay, so I'm gonna write down my factors for 10 and 100. Do we really have to do that? No, because we already know, right? 10, 20, 30, and then go on. But we already know that because we are smart. And then we have 100, starting at 100, right? So 100 and 100 is what they have in common. We already know that, we're smart. So what we're going to do is figure out how to make this 10 to 100 and a 100 to 100. So 100 by what? 100 by 10?
No. I ain't say that.
I want everyone to participate. By 1. Okay. What about 10?
10.
By 10. What we do to the bottom,
We must do to the top.
we must do to the top. Okay? Alright. Now is our denominators the same?
Yes. I said yes.
Yes.
I said yes.
Thumbs up if it's a yes for you.
Yes.
Oh, it's a lot of people. It's a no for a lot of people. Because I don't see participation, so everyone is saying no.
I ain't say no.
That means somebody probably getting their answer not correct. Alright. So
Bro.
our denominators is 100. It is now equivalent. Okay? So, equal. Now let's go to this top. 10 times 7 is
10 times 7, that's 70.
70. 20 times 1 is
21 car.
20. 70 plus 20 is 90 over 100. 90 over 100. Put your thumbs up if you got that answer correct. Thumbs up. Okay. Listen. Level zero. Level zero. Bring it back. So I walked around and I did notice a lot of people who missed a step, who got something wrong. Who wants to raise their hand and share where they went wrong? Where did you go wrong? What did you miss? 'Cause I know everyone didn't get the answer right. Tell me.
Miss Allen.
What did you miss on your first? Anaya, come tell me. Come show me what you went wrong. Where you went wrong. Anaya is gonna tell us where she went wrong. I need you to pay attention because you probably did the same thing. Okay? Where did you went wrong? Did you get 90 over 100? What did you get? Okay, show me how you got 27 over 100. Level zero. We are paying attention. Our eyes is on the board because we all make mistakes. Remember, always, if the denominators are different, we need to find the greatest common denominator.
Wait, that's a 7?
Yes.
How
Okay.
does it go?
We have to find the greatest common denominator, okay? And with this top, what you do at the bottom, remember when we find the greatest common denominator, what we do at the bottom, we got to do to the top, right here. Okay? All right? Thank you. All right. So, here we go. We are, go ahead and pull out this paper right here that I put on your desk. This paper right here. So, before we go to that worksheet, I have some candy. Let me pull out my candy jar. I need someone who can go to the board.
I'm already
Someone who can go to the board and give me the decimal form.
Wait, the whole thing or just some?
The decimal number of 90 over 100.
What? I forgot that. We did it this morning. I forgot. Oh, I got it. I think I got it.
Michael, what you doing up here?
I said to go to the board.
People are raising their hands.
I got it.
Come on, money. 90 over 100. Remember, we have this base 10 block. Okay? So 90 of these. How can we write 90 by, let's see. I'm going to give you A plus for effort. Okay? All right? But I want you to pay attention just a tad bit.
It's 9.
All right? let's do our place value. 1, 10, 100. Okay? But we are out of. We're not out of 1,000. We're not. This will be 90 out of 1,000.
That's not one. That's not how it is.
I'm a.
It's not so.
Huh?
That's not so. That's right.
Or, this is right.
Yes.
Miss Alice wrong?
Yes.
I'm gonna talk more right now.
Oh yeah, I think we had that
Wrong.
answer in.
Wrong.
Even though I wasn't here yesterday. We had that question. No, it goes 1, 2.
I don't know. Everyone say good morning, Dr. Moore. All right.